In this video, we'll look at graphing circles in polar form. We'll actually first convert it to rectangular form and recall how to graph a circle using rectangular form, and then we'll look at some shortcuts that we could potentially use if we are familiar with generic polar forms of circles. So let's just dive into an example. Remember, one of the formulas that we have is r squared equals x squared plus y squared, and we also have y equals r sine theta. Initially, we don't have r squared or r sine theta in the initial polar form, but if we multiply both sides by r, we can get that to pop out. So we'll get r squared equals 3r sine theta. Once again, just multiplying by r on both sides. Now r squared is x squared plus y squared, and then we have 3. R sine theta we will replace with y. At this point, we have the equation in rectangular form, but let's take it a step further and make it look like something that we're familiar with. So next we will set this equal to 0. We have x squared plus y squared. We'll subtract 3y on both sides, and I'm actually going to leave a blank spot and set it equal to 0. The reason we leave that blank spot is we actually want to replace that blank spot with something. And that something is the value that will make a perfect square trinomial. We want y squared minus 3y plus whatever that something is to be a perfect square trinomial so that we can more easily factor. To do that, remember, we need to complete the square. The formula that we use for that is b divided by 2 squared. Looking at the b term on the y's, we see -3. So we have -3 divided by 2 squared. That's going to give us 9/4. So we want to add 9/4 to that blank spot. Now if we add it on the left, we also need to add 9/4 on the right side. We want to keep that equation balanced. So we now have a perfect square trinomial on the y's. X is already a perfect square. The y's we can now factor. We can write this as y something squared. That something is always going to be b divided by 2. The quantity b over 2 before we square it, in this case, was -3/2. So that's what goes in here. This is called a perfect square trinomial because when we factor this trinomial, we get 2 identical factors. And then this is equal to the right side, which is 9/4. Hopefully we now recognize this as a rectangular equation, but it's the equation of a circle. And when it's in standard form like this, we can identify the center. The center is 0, 3/2. We don't see a number beside x, so the x coordinate of the center is 0. And notice beside the y we see -3/2. We want to take the opposite of what we see to plug in for the center. Then the radius of that circle is going to be the square root of this constant. The square root of 9 is 3, the square root of 4 is 2. So we have a circle centered at 0, 3/2 with a radius of 3/2. If we wanted to sketch that graph, we could get a quick sketch. Once again, the center is at 3/2, which is roughly 1.5, so roughly right here. And then the radius is again 1.5, so we're going to go up, down, left, and right 1.5 units. It's up, down, left, right. And if I had a square grid, this would look more like a circle. It's kind of crazy looking now because my grid is not square, but we have our circle. In the next example, we can use the fact that x equals r cosine theta in addition to r squared equals x squared plus y squared. We will again start by multiplying both sides of this equation by r. R times r is r squared. And then if we multiply by r on the left, on the right, we get 2r cosine theta. R squared we can replace with x squared plus y squared. Then we get equals 2. R cosine theta we will replace with x. At this point it's in rectangular form, but let's do a little extra work to make it look a little more familiar. We will again set it equal to 0. So let's subtract 2x, leave a blank spot. We're going to fill in that blank spot. Plus y squared equals 0. This time we want to complete the square on the x's. Again, in order to complete the square, we use the formula b divided by 2 squared. B in this case is -2. So we have -2 divided by 2 squared. -1 squared is 1. So we're going to add 1 to the left side, and if we do it on the left, we got to do it on the right as well. We just created a perfect square trinomial on the x's. We can factor that perfect square as x something squared. That something that goes beside x will always be b over 2. In this case, b over 2 before it gets squared is -1. So we'll put -1 there. Notice that y squared is already a perfect square, so we'll just drop that down, and it's equal to 1. We now have the standard form of a circle. So once again, we have a circle. The center of that circle is, again, beside x, look at the number and take the opposite of what we see. We see a -1, so the x coordinate of the center is +1. We don't see anything by the y. That means its y coordinate is 0. The radius of the circle is the square root of this constant. The square root of 1 is 1. So once again, we have a circle centered at 1, 0 with a radius of 1. If we wanted to sketch this curve, we could. We have the center at 1, 0. And then we'll just go up, down, left, right, 1 unit for the radius. Up, left, down, right. Play connect the dots. And we've got the circle. So when graphing circles, in my opinion, it's easier to go from polar form to rectangular form and graph the familiar standard form. However, we do have some shortcuts that may be beneficial. If we're looking at this theorem, and you don't have to memorize this, by the way, these are just ways that we can go straight to the graph of the circle when looking at the polar form. If you're given r equals 2a sine theta, we can recognize that it's a circle. The radius is going to be a. It'll be centered at 0a, and so on. All of these equations are very similar. When we're looking at sine theta, we're looking at the center at 0a or -a. When we're looking at cosine theta, we have the center of the circle being at a0 or -a0, respectively.